So these are the inner workings of our Garados sprinkler head attachment. Here we can see that we have a water solenoid, and this water solenoid goes through this 1/2-inch coupler, which then connects to this micro hydro generator, and this is what we're going to be using to power our devices. And then from here, this is attached to a generic sprinkler head. Right now we're using a Rainbird SurePop 600 series. And the neat thing about this micro hydro generator is that the thread is a 1/2 inch, which is universal for most sprinkler heads. This is our sprinkler head attachment. So here we have a hose. We have a water hose connected to our water solenoid, which Chris is activating using a 9-volt battery. This solenoid is letting water go through to this micro hydro generator. This micro hydro generator is producing right now about 21.12 volts. And this is all, the output of this is connected to the sprinkler head, which is once again the Rainbird pop-up valve, which is a generic sprinkler head. And as you can see, we have enough water pressure to produce a good stream to water our plants. Okay, so now we are testing for current. Once again, our device is running. This micro hydro generator is outputting around 16.89 volts, and that's going through this 220 ohm resistor. Now, if we do the math correctly, that should be 16.70 volts over 220. So that should be, let's see, 16.70, divide that by 220, and that gives us 75 milliamps.
So right now, what we're doing is we're charging the supercapacitors. We're charging it it's fluctuating between like 17 volts, and it's going at a 21 milliamp current. So right now, if you measure what's going into the caps and coming out, it's going to be 17.24. And if we measure the current this way too, it's about 21 milliamps. And so if I turn this off right now, then right now it's got about like 5.7 volts charged up, and it's dissipating really quick, but it slows down once it steadies. And current, it's about 5 milliamps.
Go.
We currently have 3 Nordic boards loaded with SoftDevice S10 7.2. A SoftDevice acts like a firmware that allows the application protocol CECS to be updated wirelessly. The code was originally for this NRF51 evaluation kit right here. The code was then updated to allow these other boards, the NRF51 development kits, that were later given to us by Nordic to support the same code. By pressing this button right here, the mesh network trickle algorithm broadcasts until the node receives a signal. Any node can be either transmit or receive a signal. There is no preference, which allows flexibility. Now let me show you. Pressing button 0 activates LED 1, which then deactivates LED 2 on the other boards. Activating button 1 then deactivates the other LED. Like I said previously, there is no preference. So if I press button 2 on here, it then deactivates this button and activates that one. If I come up here and press button 1, it deactivates up here and activates that one. And that's another portion of our project is connecting the UART over Bluetooth. Currently, we have the NRF51 development kit with a duty cycle of 10% every 2 seconds, and that is the advertisement mode. If it ever goes and the LED turns off, we can open and wake it back up by pressing button 1. If it's connected, then the LED stays solid green. Right now, I'm currently going to try to connect to the board. If I press connect, Garados BLE UART is right there. I select it, and now I'm connected. Being connected, I can actually send any protocols towards or through UART through Bluetooth. These buttons are currently set with different lettering. This one's wake, this one's on, and this one's off. We haven't coded it yet, but it is going to be controlling the settings for our whole sprinkler system, whether to wake up the system, turn on the system, or turn off the system. To test the buttons, I'm going to press it and use real term to see that it actually brings in wake. Go over and press on, and on turns on. Off, and then off is being sent. All this is being connected through the phone to the board wirelessly.